Find the greatest common factor is the factor tree method. Remember, when you factor using the tree method, you want to factor until all of your numbers are prime. Also, keep in mind that this tree method is easier when it comes to larger numbers. So let's begin. We're going to start out with a couple of smaller numbers, 12 and 18. Remember, my GCF means greatest common factor. So we're going to look for factors that each tree has in common. I'm going to factor 12 first. So to break it down in my tree, I'm going to draw my branches. Then I'm going to find two numbers I multiply together to get 12. 6 times 2. Now I'm going to check my numbers and see if either are prime. 2 is prime, so I cannot factor him anymore, but I will factor the 6 down into 2 times 3. Okay, all of my numbers on the bottom are prime for 12. So now I'm going to move on to 18. So I'm going to start the same way. I'm going to draw my branches for my tree and then find two numbers that I can multiply together to make 18. Let's go with 6 and 3. Now I'm going to check for prime. I have 3 as prime, but I need to factor 6. Make more branches. 2 times 3. Okay? So now what I'm going to do, I need to find all the common factors between the two trees. So I'm going to go through here and see what does this tree have as a prime factor, and does it match one over here? If it does, I'm going to circle it. So I have a 2 over here, and I have a 2 over here. I have a 3 under my 12, and I have a 3 under my 18. Now I cannot circle these two because they don't match. They're not common. So now I look at one tree and I pull all of the factors that I circled. So I circled 2 times 3 out of both trees. I'm going to do my math, multiply, and I get 6. So my GCF for both 12 and 18 is 6. Now we're going to find the least common multiple using the same method we used to find the GCF between two numbers. We're going to use our factor trees again. So what I'm going to do is I'm going to factor out 14, and then I'm going to factor out 21 down to prime, just like I did for my greatest common factor. So here we go. Draw my branches for 14. What can I multiply together to get 14? I'm going to go with 7 times 2. Check for prime. Is 7 prime? It is. 2 is prime? Yes. So I'm going to leave those alone. They are prime. Now I'm going to come over to my 21. Draw my tree, branches. What can I multiply together to get 21? 7 times 3. Since 7 occurs in both trees, I'm going to get rid of 1 because I can only use my factors one time. This is different than the greatest common factor. I like to remember this as, since I'm looking for least common multiple, I am looking for the least occurring or the least number of prime numbers. So I'm going to take each number one time from all of my factors, which means I'm going to take 7, my 2, then I'm going to come over to this tree. I cannot repeat my numbers, so the only thing left over here is a 3. Then I'm going to do my multiplication. 7 times 2 is 14. 14 times 3 42 is my answer. So my least common multiple of 14 and 21 is 42. That is the first number 14 and 21 will have in common when I multiply up. Not to be confused with factoring down. So your least common multiple should always be bigger than your starting numbers because they are going to be multiplied to get your starting number. It can also be your starting number. If 42 and 21 were being factored, 42 could be a multiple. It cannot be smaller than your starting numbers. We have found the greatest common factor of two numbers and the least common multiple of two numbers. Now, whether you have two numbers, three numbers, five numbers, it doesn't matter that you're trying to find a common factor or common multiple with. You can use this tree method. It is the easiest to see your common multiples as well as your common factors.